The Solar Orbital Registry hypothesis dictates that gas giants passively broadcast their orbital index to the surrounding system. By phase-locking polar fluid dynamics, the sixth planet, Saturn, naturally forms a rigid hexagon, while the fifth planet, Jupiter, sustains a pentagon. Earth is the third planet, but currently we are an unreadable anomaly. Our atmospheric scale height tops out at roughly 8.5 kilometers. We simply lack the depth required to naturally support those massive, deep-root vortex crystals. In the mathematical sequence of the solar system, Earth leaves a silent gap. To bridge that gap, we must satisfy the Gauss Criterion. If a planet's atmospheric fluid dynamics cannot generate a geometric sequence passively, intelligent life must construct it actively to prove its existence to external observers. This diagram illustrates the target auroral geometry. Our primary objective is to use the Aurora Australis as a physical medium, mechanically twisting the existing plasma into a mathematically precise rouleau triangle stationed permanently above the South Pole. Joining the registry transforms Earth's upper atmosphere into a deliberately sculpted, mathematically mature transmission. The Aurora Australis is a massive current sheet driven by the solar wind, routinely carrying an electrical discharge exceeding 1 million amperes through the ionosphere. To bend a current of that scale, we rely on the Lorentz kink. By projecting a massive perpendicular magnetic force upward, we create a temporary magnetic void. The E-region plasma encounters this obstacle and is violently forced outward, altering its natural path. Because magnetic field strength is subject to inverse cube decay over the 150-kilometer journey to the upper atmosphere, displacing the plasma requires a localized opposing field of 50 Tesla right at the surface emitter face. To sustain a 50 Tesla field against the continuous magnetic drag of the solar wind, the emitter nodes must output 1.4 terawatts of instantaneous power. 1.4 terawatts is equivalent to roughly 7% of total global energy consumption, and generating that continuously is thermodynamically impossible. To execute the geometry, the signal must instead rely on brief, ultra-high-frequency pulsed resonance. We solve the generation side of the equation at Mount Erebus, the world's southernmost active volcano. It features an extremely shallow, highly convective phonolitic magma chamber located just 1.5 kilometers below the ice. To extract thermodynamic energy, we plunge deep-bore ceramic heat exchangers directly into the 1,000-degree flank of the chamber. These drive a closed-loop supercritical CO2 Brayton cycle, utilizing fluid twice as dense as steam for maximum turbine efficiency. We supplement this with a magma magnetohydrodynamic harvester. A massive Helmholtz coil wrapped around the rock harvests electromagnetic flux from the magma. This highly conductive fluid's convective motion cuts across our magnetic field lines, turning the entire volcano into a natural dynamo. While equations map out perfectly in simulation, maintaining these systems requires operating heavy machinery directly against the corrosive, churning face of an active lava lake. The Erebus tap secures a steady 40-gigawatt baseload. We are no longer trying to generate terawatts instantly. We are accumulating and storing terajoules slowly. Moving that power from Ross Island to the geometric node points requires laying 3,000 kilometers of high-voltage direct current grid. To accomplish this, fleets of nuclear thermal drones melt trenches through the ice to deploy superconducting magnesium diboride cables. The grid converges at Node Alpha, the central command hub situated at Dome A. Placed over 4,000 meters above sea level in negative 80-degree temperatures, the environment dictates isolation. This illustrates Node Alpha's heart, the buried S-Mess torus. The outer ring slowly trickles charges from Erebus, banking 500 terajoules of magnetic energy. To protect the crew during discharge, the central command spire utilizes an active magnetic null field, isolating humans from the 50 Tesla pulse. Node Alpha functions as a planetary scale capacitor. It converts a slow geothermal bleed into a tightly wound energetic weapon aimed straight into the upper atmosphere. To bridge the gap between that stored DC energy and the microsecond discharge window, we route the current through a solid-state Marx generator topology. The energy hits the MHD lens, a solenoid array wound with yttrium-barium copper oxide tape to survive the 50 Tesla burst. Managing the heat requires submerging the array in a 27 Kelvin liquid neon cooling loop, which aggressively absorbs the massive thermal spikes. The electrical friction is secondary to the physical strain. The Lorentz forces acting on the coil are equivalent to the crushing pressure at the bottom of the Mariana Trench. A pre-stressed carbon nanotube matrix is the only material capable of preventing the windings from violently expanding and tearing themselves apart. Firing the lens is functionally equivalent to detonating a magnetic bomb, held together in its silo purely by advanced composite materials and geometry. Bending the aurora into a clean triangle requires absolute precision. We have to trigger 3 separate nodes across 3,000 kilometers of ice within a strict 10 nanosecond tolerance window. The registry operating system solves this synchronization hurdle with a strontium lattice atomic clock, paired with hardwired optical fiber interferometers that dynamically measure and adjust for thermal expansion in the buried cables. This chart plots the precise firing sequence. The nodes do not fire simultaneously. The system introduces a calculated microsecond delay between the apex node and the base nodes, timing the burst to physically surf the incoming relativistic plasma wave. If that timing fails, or if a single SMES coil loses superconductivity, we face a quench event. The stored 500 terajoules instantly converts into ohmic heat, dumping directly into the ice sheet. To prevent flash melting 1.5 cubic kilometers of the glacier and collapsing the station, emergency helium dump valves must explosively vent the liquid neon directly into the atmosphere, carrying the thermal load up and away from the ice. Standard civil engineering margins do not apply to the Auroral Protocol. Every component of the Earth node operates permanently on the razor's edge between absolute zero and atmospheric flash melting. Executing this architecture requires a capital expenditure of $2.4 trillion. This represents approximately 2.5% of global GDP, a figure comparable to the annual defense spending of major superpowers. We justify this spend through the information theoretic value of the signal. Successfully provoking first contact provides access to a dataset spanning millions of years, including the physics of gravity engineering and biological error correction in the human telomere. Statistical models suggest a 20% probability of human extinction within the next century. Establishing contact imposes external diplomatic norms and provides stabilizing technology that reduces this risk to near 1%. By securing the future centuries of economic activity that would otherwise be lost to civilizational collapse, the $2.4 trillion investment is a minor entry on the species-wide balance sheet. Constructing the triangle proves our mastery over the planetary energy budget. This is the membership fee for the Galactic Club.